Hello, and thank you for joining this talk on the evolution and conservation of New Zealand parrots. Now, New Zealand is, of course, a country of the birds. It has many examples of evolutionary pathways, including island giantism, flightlessness, adaptation to rapidly changing environments, that really make the New Zealand bird fauna a good model for studying evolutionary processes. But New Zealand bird fauna is also highly threatened. Since the arrival of people in New Zealand about 700 years ago, we've lost nearly 40% of the New Zealand native bird fauna or endemic bird fauna. So clearly conservation research is a very important part of what we are doing. And so what we've been trying to do for the last couple of years is really look at this intersection between evolutionary genomics and conservation genomics. So we're looking at the evolution of a species, but also try to infer what's this evolution, what we can learn from the evolution of a species for our conservation management of the species. And I want to give an example of such a study today that we recently published. And this is looking into specifically the evolution of the kea and the kaka, two parrot species in New Zealand. The study was conducted by Denise Martini, a PhD student in our team, and it was based on whole genome data. So basically, the story of the evolution of the kea and the kaka is closely linked to the uplift, or the rising of the New Zealand Alps, the Southern Alps, which is this backbone of the South Island that you can see here in the satellite picture, which started around 5 million years ago. So the theory goes that you have an ancestral species of these two parrot species, the kaka and the kea, that lived in the forest. And then we have the uplift of the Alps, creating a viable alpine zone from maybe 3 million years ago or so. We have populations of this forest parrot starting to utilize the alpine zone, adapting to the alpine zone, and eventually becoming the kea. If that was so, the kea would be an alpine specialist. The divergence of kea and kaka, the evolution of the kea, would have been driven by the kea's adaptation to an alpine environment. And if that was so, that would be a bit of a concern, because of course, in a warming world, the New Zealand alpine zone is going to shrink, and kea are already not doing particularly well. So a shrinking alpine zone would be a massive conservation concern for the species if they are really a purely perfectly adapted alpine specialist. But there are some questions on whether that's actually the case. So kea have been described as New Zealand mountain parrot. They're in fact sometimes described as the only alpine parrot in the world. It's not true. There are other alpine species, but kea is perhaps the most iconic one, if you like. They're usually found in the alpine zone. In fact, they're usually found in car parks, on top of cars, doing some recycling work, as you can see here. They are today endemic to the New Zealand South Island, and as I said, usually in the alpine zone. But there is fossil evidence from the North Island for kea and from areas that are much more lower lying. In fact, even today, where they're not disturbed by kaka or by people, where there's a bit less competition, you can find them down to sea level. Usually you find them in alpine zone, but they are also found at lower levels. So not really a perfect example of an alpine species. And so we were wondering, is the kea really an alpine species? Is the evolution of the kea really driven by this adaptation to alpine habitats? And the theory is that if that was so, then what we should see is selective pressure on genes or pathways associated with alpine adaptations, specifically in the kea, but not in the kaka. And this is what we were trying to understand. So was the divergence of kea and kaka driven by alpine adaptation of the kea? And if so, what are the implications? So what Denise did is she sequenced kaka genome to relatively good quality. The kea genome was already published from a bird, a captive bird in Copenhagen Zoo. So we were able to utilize that, and we sequenced the kaka genome. In fact, we sequenced several kaka genomes, and we combined North Island and South Island genomes to get sort of a species-wide overview. Here are some quality statistics: 90-fold coverage, about 89% of the AVIS database orthodox were present, 16,500 genes, putative functions assigned to about 97% of them. So it means it's a good average genome. It's not comparable to the long-read genomes or the chromosome level genomes that are now being produced, but it is a decent quality. And in fact, the Kaka genome assembly was good enough for us to remap the Kia against it and actually improve some of the Kia assembly. The first thing we did is just reconfirm the divergence time of Kia and Kaka based on the whole genome data, just to make sure that we're still really looking at this divergence time that is that works with this theory of alpine uplift driving the divergence of the two species. And we found an average or a peak divergence time of about 1.8 million years, quite a wide error margin from 750,000 to 3.9 million years ago due to some calibration uncertainties, but certainly a time frame that would be consistent with the alpine explanation of Kia-Kaka divergence. So that lets us get to the meat of the study. Do we see any evidence of positive selection in Kia and Kaka? And where do we see this selection? We do see positive selection in 79 genes for Kia using just standard DNDS tests, in 93 genes for Kaka. And in fact, when we look at these genes and pathways under selection, we do see evidence of pathways under selection that are associated with alpine adaptations. So inflammatory response, cardiovascular development, energy homeostasis, but they are all under selection in both the Kia and the Kaka. So this probably goes back to an ancestral species. It might have facilitated the Kia's ability to utilize the alpine zone, but it is not what has been driving the divergence of the two species. Both show adaptations to alpine environments, selective pressure on adaptations to alpine environments. Another theory was that perhaps the famous inquisitive, adaptable behavior that we see in the Kia, it's something to do with its ability to utilize the harsh alpine zone. And in fact, we do again see selective pressure on pathways that we know are associated with behavior, neurodevelopment and sensory perception, some pathways associated with cognitive abnormalities in humans, problem solving. But again, they're both under selection in both the Kia and the Kaka. So they're not driving the divergence of the two species. In fact, we think they probably just reflect the development of higher cognitive abilities in parrots that has been described in recent genome studies already. So we really don't see any major evidence for selection associated with alpine adaptations in Kia only. And I'm well aware that the NDS tests are not particularly good at picking up selective signals, recent selective signals. So perhaps the divergence time of the two species is just too recent for the approach that we've chosen here. But I don't actually think we need this alpine adaptation to explain the evolution of the Kia. And in fact, we can do that better, fitting the data better with a different explanation. New Zealand was densely forested for the best part of the last 15 or 20 million years. And only when the ice ages arrived, about 2.5 million years ago, we see widespread deforestation, especially in the South Island, but also in parts of the North Island, as a result of the glacial climates. And of course, a forest species such as our ancestral parrot would have come under pressure from this massive deforestation, from this massive loss of habitat. And it's not a stretch to assume then that some populations of this ancestral parrot would have ventured out into the open habitat, trying to find resources there, being under pressure in the forest habitat. And then again, it's not a stretch to assume that these populations that ventured outside of the forest eventually diverged from the forest populations and became the Kia. And if that was so, then it's not so much the alpine habitat or the loss of alpine habitat that we have to worry about. It is perhaps more the loss of open habitat. In fact, I would suggest that perhaps some of this alpine specialization that we see at the moment could be a result, or partially a result, of the bounty that's been on the Kia for the best part of 100 years. Whenever the Kia came into the lowlands, came into proximity of people, they were shot. From, I think, the 1860s to the 1970s, there was a bounty on their head. And so it's not surprising that perhaps now we find them in more inaccessible parts of New Zealand. So for conservation, what does that mean? Well, essentially, we need to worry about having refuge areas, open habitat refuge areas for such species as the Kia, like, for example, the Mackenzie Basin that we can see here near our Rocky Mount Cook. These are areas which are below the alpine zone, which are open habitats and may form refuges for such open habitat species. There has been discussion in the past that this area should be developed, should be turned into more dairying rather than sheep farming. And I think these are the things that we need to keep in mind, that they might be quite risky. But it's not so much the alpine zone, at least not for the Kia, that is the critical point for their survival. So I hope this gives you a bit of an overview of the work that we've been doing. It's just one of the studies that we have been doing, focusing on individual species. This is a team that has worked on it, as well as the collaborators and the kaitiaki, the guardians of the birds that we have sequenced. And we are very grateful for the support also from the Royal Society for the funding that we've received here. And of course, thank you for listening. Bye.